So today we'll discuss the periodic table chapter from class 10 ICSE board. So here I am following basically Dr. Dalal's book. First is that what is called period. Period basically the number of electronic cell is the number of the period, right? So what we'll see is that nitrogen the atomic number is 7. If you see the electronic configuration is 2 and 5, right? So basically 2 electrons are there in the first cell, and in the last cell it is 5 electrons. So the number of cells is 2 here, right? So the period it will be 2 only. Now if you see for sulfur has 16 electron total. The electronic configuration is 2, 8 and 6. So the number of cells is 3. So period it will be 3 only. Now if you do by yourself, in case of oxygen has 2 period, because that has 2 number of electronic cells. Now if you see in case of period 1, like there are 2 elements total, right? Hydrogen and helium. In period 2, if you see there are 8 elements. In period 3, similarly again another 8 elements. In period 4, it is 18 elements total, right? In period 5, 18. In period 6, there are lanthanide. So including those, it will be 32 elements. In period 7, 32. So total of 112 elements present in the periodic table. Now we'll see what is called bridge element. Bridge elements basically shows the similarity in the property diagonally with the periods in the next group. If you see in the period 2, there are lithium, beryllium, boron. In period 3, it is sodium, magnesium and aluminium. So it is found that the lithium and magnesium, they are basically present diagonally, and they have the similarities in the properties, right? So these are called bridge element. In a similar way, beryllium and aluminium, if you see, they also placed diagonally. So these also called bridge element. It is present in period 2 and period 3. Now one by one we will see. In period who is present? Period 1 basically hydrogen and helium is present. In case of period 2, if you see, there are total 18 group, right? This horizontal lines are called period, and the these things columns are called group. If you see, total 18 groups are present. Group 1, 2, then transition elements groups are present, and after that starting is group 13, 14, 15, 16, 17 and 18 group, right? Okay, so in this group, what are the elements present in case of period 2? If you see, first element is lithium, then it is beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Now their atomic number, if we consider lithium is 3, right? If the atomic number is 3, the electronic configuration it will be 2 and 1. In beryllium it is 4, so the electronic configuration is 2, 2. In boron it is 5, right? Total like atomic number is 5, total number of electron is 5, so the configuration is 2 and 3. In carbon it is 6, so the configuration is 2, 4. In nitrogen it is 7 electron total, so the configuration will be 2, 5. In oxygen it is 8 electrons, so the configuration will be 2, 6. In fluorine it is 9 electrons, so the configuration is 2, 7. And in neon it is 2 and 8, right? Now if you see their nature, their state basically, you know that group 1 and group 2 are basically the group of metals. So the first group and second group, in the period 2, lithium and beryllium, they are metals. Then it is coming for boron it is the metalloid, and after that non-metal groups are present, like group 14, 15, 16, 17 and 18. Here carbon, which is non-metal, nitrogen non-metal, oxygen non-metal, fluorine non-metal, and neon is the inert gas, right? Now we'll see the valency. Valency means what? Valency means you can say the combining capability, right? Combining capacity, that is called valency. How it can combine with other elements. Generally these elements, how many number of electron they need to accept or donate, right, to get the nearby inert gas configuration. So that is what their valency is called. If you see in case of lithium, the configuration was 2, 1. So if 1 electron it is donated by lithium, it can get the configuration of helium. so the valency is 1 here. In case of beryllium, the valency is 2 here, right? In boron, if you see the 3 electron it is there, so the valency is 3. In carbon it is 4. In case of nitrogen, if it is accepting 3 electron in the outermost orbital, so it will be, the configuration will be 2 and 8, right? If nitrogen, if it is accepting 3 electron, so it will be 2 and 8, the configuration will be 2 and 8, so it will get the electronic configuration of neon. So the valency of nitrogen is 3, the valency of oxygen it is 2, right? Only 2 electron needed to fill the this electronic configuration of 2 8. Then fluorine, the valency is 1, and in case of inert gas the valency is 0. Okay, so now we are coming for the period 3. In the period 3, similar way, what are the elements are present here? If you see the first basically group 1, so their element is sodium, then magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Okay, their atomic number is 11, 12, 13, 14, 15, 16, 17 and 18. For 11, the electronic configuration is 281, and here if you notice 281, so the number of electronic cells is 3. That's why they are placed in period 3. All the cases if you see, the number of electronic cells is 3, so their period is 3. In case of magnesium 282, then aluminum 283, so 1 electron added here up to group 18. Okay, now see the state. So we know that group 1 and group 2, the basically metals are present. So sodium is metal, magnesium is metal, aluminum is metal, and silicon basically coming in the group of metalloid. Okay, silicon, it is basically the metalloid. Then phosphorus is non-metal, sulfur is non-metal, chlorine is non-metal, and argon is the inert gas. Okay, now we are coming for, if they are forming the chlorides, what will be their nature? Okay, so if sodium is forming chloride, then it is called sodium chloride. The formula will be NaCl. If you remember, if you know the valency, so you also can form their chloride. What will be their formula? Let's say magnesium chloride. So magnesium valency is 2, chlorine valency is 1. So if they are forming the magnesium chloride, the formula will be MgCl2, right? They will get the subscript of their valency, means basically cross, there will be a cross, and they will get the subscript of their opposite ion valency, right? So if you see, in case of aluminum has valency of 3, chlorine has valency of 1, so aluminum will get the subscript of 1, chlorine will get the subscript of 3. The formula of aluminum chloride, it will be AlCl3. In case of like if you see the silicon chloride also, silicon having valency of 4, chlorine is having valency of 1, so the silicon chloride, the formula will be SiCl4. Okay, now we will see their nature. If you see sodium chloride, magnesium chloride, aluminum chloride, silicon chloride, and in phosphorus it will be first this pentachloride or trichloride. Okay, then it is coming H2Cl2, sulfur chloride. So what will be their bonding? In case, you have to remember that every time if their basically metal and non-metals are forming the compound, then it will be ionic, and if both are non-metal, then it will be covalent. In NaCl, if you see metal bonded with the these things non-metal, so it will be ionic bond. In magnesium chloride also it will be ionic, aluminum chloride also it will be ionic. Silicon chloride is both are non-metal, so this is basically covalent. For PCl3 or PCl5, both are non-metal, so it will be covalent bond. In H2Cl2 also they are forming through the covalent bond. Now if you see the states, if you see NaCl, MgCl2, AlCl3, all are solid only. SiCl4 it is liquid, and then in case of PCl3, PCl5, they may be liquid or solid, and H2Cl2 also liquid. Okay, now we will see their oxides. If oxygen is conjugated with this metal or non-metal, they will form the oxide. And one very important thing we have to remember, that if metallic oxide, then it is basic oxide. Non-metallic oxides are always acidic oxide. Okay, so from there also we can say is it basic or acidic. If you see sodium oxide, sodium oxide bonding is ionic, that we know, because it is like it is formed through metal and non-metal, so bonding will be ionic only. But this is metallic oxide, so metallic oxides are always basic oxide, right? Magnesium oxide, that is also basic oxide. Aluminum oxide, basic oxide. Okay, silicon dioxide, this is basically the non-metallic oxide, and we know non-metallic oxides are acidic, right? Non-metallic oxides are acidic. P2O5, as it is non-metallic, so it is acidic. SO2, SO3, they are basically acidic oxide. Okay, Cl2O7, this is highly acidic oxide. So this is basically the part 1 of periodic table from class 10. So next part will upload it. Okay, and you remember these things. If metals are connected with oxygen, then they are called metallic oxide. If it is non-metal, then this is called non-metallic oxide. Okay, thank you so much. So if you like this video, please don't forget to subscribe the channel and like and comment, and if you have any doubt, you can write down in the comment section. Okay, thank you so much.